So if you do any kind of programming in NX, you're going to know that there's a lot of different ways to do anything. A lot of it comes down to your preference, the individual feature. So this afternoon I'm going to show you a couple different options you have for multi-axis contouring and some surfacing options. First, we're going to go with probably the most simple, and that's just a tilt tool axis. Pretty much you just program a normal 3-axis operation, and then you have NX automatically adjust the axis to account for any kind of collisions, to avoid tool collision or tool holder collision or a shank collision. So, like I said, it's pretty basic. You just program your 3-axis operation. Generally, this is for kind of more simple geometry, stuff that not the most complex in the world, but maybe it's like a deep wall, or there's just one little spot that you're kind of concerned about, and so this is a quick way of programming it and just having NX automatically adjust for any collisions. And then once you have the toolpath operation programmed, you just right-click in the program order view in the operation navigator and go down to toolpath, and then there's a little option that says tilt tool axis. One thing to note is because this is after the operation is generated, it is editing the toolpath, and so if you regenerate the operation, the tilt tool will go away, and so you can check by checking the path column. If it's got a checkbox next to it, then that means that the toolpath isn't edited. So if you added a tool tilt and you regenerate it and you see this checkbox, then you better watch out because there's no tilt anymore. But if you see the little wrench, that means that the toolpath is edited. Doesn't necessarily mean that it's the tool tilt axis is applied. It could be you could go into the toolpath and manually edit. Any of these options in the toolpath will create an edited toolpath, except for the stuff that like list that just tells you what it is. I'll show you a quick example of that. So here we have just kind of a simple pocket, but it's kind of deep, and you kind of have this kind of cutaway area right here. So we just did a fixed axis streamline and just had it helical down right down to the bottom. So it's pretty quick. I'll go ahead and just create that one real quick. So insert operation, go to mill contour, fix contour, grab our tool. So because I use a cut area geometry group, my cut area is already selected. And we'll switch down to streamline, and we'll identify our guide curves. It'll automatically try to identify it based on what NX believes you're trying to do. It tries to be intuitive. And so we'll get the top and then down at the bottom. And then we'll add a cross curve to connect the two. You don't always need a cross curve, but sometimes it helps to just kind of constrain all of the features and just creates a nice smooth tool path. So we just want to connect the two. We'll leave our tool position as tangent too, and we'll switch our cut pattern to helical spiral. We'll change our step over. Because of the demo, I want to keep the generation time down. We'll do, let's try 35. We'll just hit OK. Then we'll just do our projection vector, do toward drive. And so this is just to get the 3-axis programming. If you guys don't understand any of this, I'm kind of going through this part a little bit fast. I can talk with you guys after the presentation. This is just to get our basic 5-axis toolpath. And we'll keep our tool axis at Z normal. Just generate. So pretty quickly we have a pretty, pretty smooth toolpath, with the exception of it, kind of collides a little bit, which not going to work. But all you'd have to do is toolpath, right-click, toolpath, tool tilt. You go to collision avoidance. Because this has a reduced shank, I can just leave that at 0 for now. And we'll put the clearance for the tool holder at 50 thou. And so it's just going to run through the tool in kind of the background, and it's going to identify areas that the tool holder will get within 0.05 inches of the part, and it will tilt the tool accordingly. One nice thing about this is that if there's no collision, detected, it will keep the tool axis at Z normal. So you're not doing any kind of unneeded tilting or retractions or anything like that. So you can look at our toolpath. So it stays Z normal, but then as it goes down, you can see that it tilts. Just do a section view. And you can see that it stays away from the part. So this is just a really quick way of creating a 5-axis toolpath out of a 3-axis operation. We use it quite a bit. It's a real quick way. You're not spending a lot of time trying to identify the correct tool axis or anything like that. So the next operation we're going to do is contour profile. Contour profile adds a little bit extra level of difficulty, especially with the demo part that we have coming up. This is for a 5-axis wall, essentially with no floor. So we're going to create an auxiliary floor that we're going to essentially drive the tool along the bottom of while staying against the wall of the part. So the things to keep in mind here is you're going to need to create an auxiliary floor geometry. It's pretty simple as long as you have the appropriate licenses. And then you just create a contour profile. Make sure your geometry is selected. You're going to select the walls and then auxiliary floor. You're not going to need to select any floor geometry for this operation. And then make sure your drive method is contour profile, because we're just going to drive along that wall. That's the whole point of this operation. The tool axis, a lot of times automatic works just fine. That's the default. Aligned edges will guarantee that it stays against that wall. For this particular operation, you really have to zoom in to see any difference between automatic tool axis and aligned edge. They're very close. And then one of the most important parts is make sure that in your drive settings you have follow wall bottom, and then your tool position offset, you need that to be at least the diameter or at least the radius of the ball end mill that you're using. That way that the radius of the ball or the tip is below the wall. That way you can make sure you get full cleanup on the wall. And you can go a little bit more if you need to. It needs to be at least the radius. So here's our sample part. And so here we have a pre-programmed contour profile using the auxiliary floor. And our auxiliary floor is just an offset end-sided surface. And I'll show you how to make one of those real quick. But one thing to note is the operation that uses it with that auxiliary floor, you'll notice that the corners are nice and smooth. all those. But if you don't have an auxiliary floor, while most of it looks okay, you'll notice that it gets a little choppy in the corners. Depending on your situation, that might be okay, but creating the auxiliary floor just makes a much cleaner tool path. And so in order to get that auxiliary floor, you just go into your modeling application. And that's one great thing about NX also is the CAD-CAM integration. And so, you know, even though I primarily focus on the CAM side, you know, I'm still in CAD, making geometry, making simplified models. It just makes your life a lot easier a lot of times. Not to say you need to. A lot of times you can get the same outcomes using no CAD at all, or no modified CAD, but it might take you a little bit longer, it might take a little extra clicks. And if you use the CAD and CAM together, you can really enhance your programming. So inside modeling, you can just select inside surface, and you just select the bottom of the wall. It's a little bit more tricky without a 3D mouse, but you can get it done. And so this surface is going to try to contour to the curves that you selected. And so we don't need a exact floor, but this gives you a pretty good representation. And so it's going to suit our purposes just fine. And once you have that wall, you want to offset it about the same amount that you're going to do your tool tip offset. And so you just offset the surface. You can see here, before you used to have to right-click, hide, but now you just show what you want. You go back into application in your manufacturing. So we're going to just insert operation. Multi-axis, contour profile. Select everything that you need. Make sure that you don't over-select. Select your auxiliary floor that we just created. Tool latches line to edge, floor bottom. And then with your access vector, you just want to tell it which direction this tool is coming from. It doesn't need to be precise. You don't need to create a whole new CSIS or anything like that. You simply just go to specify, and just kind of pick roughly a spot on the surface. Make sure it's pointing up. It takes a little bit. Go ahead and hide our offset surface, our auxiliary floor, and you'll see that we have a nice five-axis toolpath here. And it just follows along that wall. And so, like I said, you could create that without an auxiliary floor. There's ways around it, but it's a lot faster if you make an auxiliary floor and just drive along the bottom of that. All right. And so now we're going to get into a little bit more of the variable axis guide curves. And so with variable axis guide curves, was originally introduced in NX12. I believe it was 1201 variable axis guide curves was introduced, and 1202 fixed axis guide curves were introduced. With 1847, they've improved the generation behind it. It still takes a little bit of time, but the toolpaths in 1847 are a lot smoother. They've done a lot to refine the generation in the background to ensure that you get the best possible toolpath. So the question was, are guide curves, variable axis guide curves or fixed axis guide curves locked into ball nose or ball end mills? At the moment they are. I think it's still in beta, but they're working with barrel mills now. And so they're just kind of slowly introducing that. I believe the next step is barrel cutters. I know it's in beta. They might have finally released barrel. I can't remember. But then the next step will be tangential barrel, and then slowly working out of that. And so another nice thing about variable axis guide curves is that kind of like I mentioned before about cut areas needing to be part of workpieces, variable axis guide curves don't need that. They're not adherent to the cut area being required to be part of the workpiece. And so I'm going to show you a little bit of these three operation types. So we're going to do a zigzag using a patch surface, and we're going to do a spiral operation without a patch, and I'm going to show you how to do a helical profile where the tool tilts, kind of like we did with the tilt tool axis, but variable axis guide curves does it automatically within the operation, so you don't have to go in and right-click toolpath, tool tilt. So first of all, you'll see that on this part, I've patched the surfaces, and patching surfaces with NX is actually really easy. So inside the modeling, you just go to patch openings. You can customize everything. I believe patch openings are inside. They're in one of these menus, but I always just, because I use it so often, I just add it to my toolbar. Or you just go to your command finder and type it in. It makes it so much faster. You can put it right where you need it, and so it's always there. You don't have to go digging for it. And so I'll just open up one of these ones that I've already done. And so with patch openings, essentially all you're doing is doing exactly what the feature says. You're patching an opening. So you select the face that you want to patch, and then you select the edges that you want to fill in, and it does everything else for you. Kind of like inside surfaces, it will do its best to continue the surface contour. But if you noticed with the inside surface, my edges weren't really trimmed. You can trim them, but the patch surface will really make a nice trim surface for your construction surface, your patch surface. And so I just went ahead and patched all three of those. And so all three of these are variable axis. And so with our workpiece selected, you'll see that our patch is not part of the workpiece, but our cut area, right there, the face and our patch are the cut area. And then inside the drive method, make sure your guide curves is selected. We have morphing, so it will take our two guide curves that we select. In this case, it is edges on the part. It doesn't necessarily have to be. It can be construction geometry that you have projected, or if it's just kind of just floating above the part, it will, as long as it's close. It doesn't need to be perfect geometry on the part. It will do its best to identify the cut area and then take your drive geometry and project it onto the part. And so with morphing, it will go from one end to the other. So you can either go from guide 1 to guide 2 or guide 2 to guide 1. That's just selected down here in the cut order. And so for our guides, we just selected the direction, following the direction that we want to go, the first edge and then the second edge, and that's it. Because we want zigzag, we'll leave it as the default, and you just set your scallop to whatever scallop you want. With the tool axis, for this one, we have normal to drive, because it just produces a nice, easy toolpath. You have a bunch of different options. You can do fixed with avoidance selected. That's going to be our final operation. I'll kind of go over that a little bit more in detail later. So I'm not going to generate this because guide curves takes a little bit of time to generate, and you're just watching the wheel spin. But if you look at it, so we can go ahead and just select any part of the toolpath. It's just going to stay normal to the surface, and just cut that surface tilting as it needs to. It's a really good way. You could theoretically select all of the faces and just continue this all the way around. Might take a little bit of time to generate, depending on how fine of a step over you want to do. But that's very possible. You could do that without a problem. And so our second operation is going to be under the assumption that we've already cut out this hole, so we're not going to want to recut open air. So we're just going to go ahead and hide our patch surfaces. And so just like before, we have our workpiece and our cut area defined, this time without the patch. You go inside the guide curves drive method, and just like before where we went from one edge to the other, we're going to just do the outside border and then select the inside border. And instead of zigzag, we'll select helical, and then pretty much everything else is the same. And so it's going to just do a continuous toolpath. It's going to, compress the toolpath in a thinner area and kind of extend it out, widen it out to our maximum scallop height in areas that it can. So it's just going to do its best to kind of, morph it, which is exactly what it says. Kind of just squeeze where it needs to and expand where it can. And so just like the other toolpath, it's going to be normal to drive. And it's just going to flow right around that part. And so it's a real quick way to do some really intricate surfacing operations, especially these ones where there's not really any issue of collision. Makes it real fast. And so our final operation is just, we're going to assume that we just want to profile all the way down this whole part. And so this one uses the patches once again. So you'll see that the workpiece is selected and the cut area is also selected with the patches. Once again, use morphing. Extend this out. And so in the past, we used two guide curves, start and end points. With this one, we're going to use 4 different guide curves and essentially just kind of work our way down the part. We could theoretically morphing just needs a minimum of 2 guide curves. Constant offset needs 1 guide curve, and it'll start that guide curve and it will just work its way at a constant offset. Morphing will take minimum of 2 and just kind of morph in between or step over as it can between the different drive curves. And so the more you select, the more it's going to hug the part essentially. It's not going to, it's going to flow with the part a little bit better. Do keep in mind the more guide curves you select, the more time it's going to take to generate because it's going to be, even more precise. NX is all about precision a lot of times, and so the more guide curves you select, the more it's going to hug that part. And so like before, this time we're going to keep helical and everything else is the same. This time, because we're not going to just be normal to the geometry, although we probably could, we're going to change the tool axis to fixed still, but we're going to change it to fixed and then with the orientation to the Z positive. If we're on a horizontal, we could do, or if this part was orientated in a non-Z positive, then we would just specify the vector. It's not anything specific. The difference is we go into the tool tilt, and so just like on our first demonstration part where we generated a 3-axis toolpath and then tilted the result, this has the tool tilt built inside of the operation. So if we go into that, it looks a little bit different, but all the information is essentially the same. It's asking you, for this one, it's asking if you want to rotate or tilt. Depending on your machine, you might have a preference one way or the other. Default is just equal. And so, and you can set all these different parameters depending on your guys' own preference or your machine capabilities. The important part is these clearances right here. Just like before, you set however far you want to stay away from the part. The tool holder will stay 0.5 millimeter away, the tool shank will stay 0.3 millimeters away. And so if you visualize it, you'll see that it stays with the Z normal axis the best it can. And then it will just tilt away as it needs to. And it will just helical all the way down. And so it's a really good way to machine some really complex features in a really easy toolpath. Like I said, it does take a little bit of time to generate, but you're only doing one operation. You don't have to do multiple operations for this. So that's all I really have for the 5-axis and contour surfacing. Does anyone have any questions about any of these examples?